excitable cells. So already we had discussed this. Excitable means that can respond to a stimuli. It is known as what? Excitable. Kritika is very good. It can respond to a particular stimuli. That is excitable. So next thing, so because their membranes are in a polarized state. Here, what do you mean by polarized state? What do you mean by polarized? Polarized means the membrane potential. Selvadashini correct answer. Sangavi Sumana Hasin correct answer. So the membrane potential is what? Minus 70 millivolt. Membrane potential average. Here is minus 70 millivolt. That is average. Yes. So average membrane potential. Here membrane means what membrane? Dharnidharan, yes. Here membrane means oxolemma. Very good. Darshini, Shruti, Krishna, Kritika, Karti, Ashwat. Here membrane means oxolemma. So the outside of the oxolemma, yes. At the membrane, on the membrane, what potential may be there? Minus 70 millivolts. So this condition is known as what? Polarized. So next one, so this particular oxolemma can be brought about to what? Brought about to what? Yes, 45 millivolt, yes, membrane potential. So that condition is called as depolarized. Okay, yes. So negative potential minus 70, that can be brought about to what? Plus 45 membrane potential. Yes, that condition is called as depolarization. Dharnidharan correct answer. Everybody has understood. So excitable means if it is brought to plus, I mean above the threshold, not only plus 45, above the threshold. If it is brought about to threshold stimulus, what can be produced? Action potential can be produced. So that is known as what? Depolarized. That is all. Yes, Selvadashni, yes. So the threshold stimuli is minus 55. We can discuss. So for the conduction, different types of ionic channels. Ionic channels are present on the neural membrane. So these ion channels are selectively permeable to different ions. So what do you mean by selectively permeable? So that will allow the potassium, but not sodium. So this is what? Selective. Got it, ma? Selective means what? That will, I mean, this membrane is highly permeable for what? Potassium, not for sodium. So this is what? Ionic channel. So which is what? Selective permeable to ions. Selective permeable to ions. If a particular stimuli is applied, what will happen? Sodium potassium ionic channel opens. If no stimuli is applied, the sodium potassium ionic channel will not open. If a particular stimuli is applied, the sodium potassium ionic channel open. So selective at that time, what happens? Sodium, that is permeable to sodium. So before that, that is permeable to potassium ions. Whenever a stimuli is applied, that is permeable to sodium. So whenever no stimuli is applied, that is permeable to potassium. Got it, student? Who will explain this? Please raise your hand. I give you a chance. Who is ready to explain? So now see. Now see this in this diagram, you can see. See sodium ions that enter into the cell. Likewise, potassium ions that go out of the cell. I mean oxoplasm. So this is what? Oxoplasm. This is what? Oxoplasm. So sodium ions and potassium ions. Okay, so they are what? Moving in and out. So sodium ions, you can see, enter into the cell. Potassium ions, so exit out of the cell, oxoplasm. So here sodium ions, see students, sodium ions, when will it enter? Whenever a stimuli is applied, sodium ions enter. Through what? Through what? Sodium potassium ionic channel. Through what? Sodium bump. Through what? Sodium bump. But potassium ion, so the membrane itself is what? Permeable to what? Highly permeable. Permeable to potassium ion. So potassium ions frequently what? So that goes out of the cell, that may enter into the cells. So whenever not a stimuli, so I mean in time, so where no stimuli is not applied. So other than the stimuli is applied in other time where no the stimuli is not what applied. So sodium ions that moves inside whenever stimuli is applied. What about the potassium ions? Regarding the potassium ions, the membrane is what? Permeable. So highly permeable. So the restriction is for what? Sodium ions only. So this condition is known as what? This condition that may changes the membrane potential. So already negative potentials on the membrane. So that is called as what? Polarized. So the change, migration of sodium and potassium ions in and out, that may bring about what? The change of what? The membrane potential, so that what will happen? From polarized state to depolarized state will be established. From polarized state to depolarized. So that mechanism only we are going to discuss. In what way the polarized turns into depolarized. So that only we are going to discuss. Okay. So now the electrical potential difference across the resting membrane. Resting membrane is called the resting potential. So here resting potential means while doing some work or being at rest. Here being at rest, that means what? Not being in sitting position. Being at rest means here what does it mean? Resting means stimuli is not applied. Okay. So resting means what? Stimuli is not applied. So that condition is known as what? Resting potential. Okay, students. Got it? So in a neuron, stimuli is not applied. So that condition is known as what? Resting potential. Did you get it? Chat to me. What do you mean by resting potential? 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 Chat to me. Chat to me, students. What do you mean by resting potential? Resting potential minus 70 millivolt we know. But what do you mean by resting potential? Have I to once again explain? Have I to once again explain? Did you understand it? Ashwath, understand it? Did you understand it, ma? Salvadash, did you understand it? Did you understand it, ma? Am I audible, sir? Am I audible, sir?
Yes, sir, audible, sir.
But no chat is displayed. The friend is.
Sir, chat option actually it is given to host, but chat comes to my ID.
Okay, sir. So, but please change me host, sir. I can't see that. So I can't see the chat, sir. Please make me host, sir. Okay, students. Okay. Yes, now appearing, sir. Yes. Shritika, yes. Now appearing. Okay. Yes, sir. Now it is possible.
Yes, sir. Continue, sir.
Okay, students. Yes. So I couldn't see your chat, ma. So that one. Okay. Okay, students. Yes. So the resting potential, no stimuli is what applied. Yes. Ashwath, Abhinitya, yes, very good. Sumana Hazin, yes, ma. Very good. Yes. Karthi, yes, ma. Very good. Salvadashni, yes. Very good, ma. Yes. So next one. Yes. So when a stimuli is applied at a site, see A on the polarized membrane, the membrane at the site A becomes freely permeable to sodium. So here what does it mean? Here what does it mean? See. So see, this is what? A neuron. This is what? A neuron. So now take it as what? Oxoplasm. So this is what? Oxolemma. So inside what's found? Oxoplasm is found. So now at first the condition is what? At first the condition outside of the neuron, what may be found? Large number of what? Sodium ions will be there. So sodium ions outside. So what about the oxoplasm? Here potassium ions will be there. So when the condition is what? Negative. Okay, negative membrane potential. So inside, resting potential. I talk you about what? Resting potential. Yes. So inside what will be there? Potassium ion. So this membrane, I discussed with you. This membrane is what? Highly permeable to what? Sodium or potassium. Highly permeable to what? Sodium or potassium. Yes. Potassium ions, not sodium. Yes, potassium ions. Yes, very good. Kavinetra, Dharnidharan, Harshida. Yes, very good. Potassium ions. Now, inside the oxoplasm, what are all the other things present? So, negatively charged proteins are also present. Negatively charged proteins are also present. Okay, got it. Negatively charged. So, even though potassium ions are found inside the cell, due to the presence of this negatively charged ion inside the cytoplasm, what charge will be there? What charge will be there? Even though the potassium ions are there, yes, negative charge, because the number of negatively charged proteins are numerous. Yes, Ranjit Kumar, Madhusri, okay. A large number of negatively charged proteins are found inside the oxoplasm. So the condition is what? Even though the presence of potassium ions inside the oxoplasm, due to the presence of, because of the presence of these negatively charged proteins, the oxoplasm seems to be what? Negative. The oxoplasm seems to be what? Negative. Okay, ma, yes, negative. But what about the condition outside of the membrane? What about the condition of the outside? Yes, positive. Yes, very good. So outside, what will be that? Positive. Yes, very good. But the number of ions, concentration, that is when compared to potassium outside, that is 14 times. That is 14 times. But here inside, 30 times. So even though 30 times highly concentrated, due to the presence of negatively charged ions, that seems to be negative. So always during resting potential, during a resting time, so whenever the neuron is getting resting potential, inside that seems to be electronegative. Inside that seems to be what? Electronegative. So at the time of getting negative, at the time of getting resting electric potential, membrane potential, what's the charge of outside of the neuron? Whether positive or negative? Check to me. Yes, positive. So always positive. Yes, during resting membrane potential. Yes. Then inside the oxoplasm. Yes. Inside the oxoplasm, electronegative. So outside electropositive, inside electronegative. Yes, very good. Karti, Dhanushri, yes, very good. Dharni Dharan, yes, very good. So next, so how electric potentials are produced? Actually, electrical potential means electric impulse. So electrical action potential means what? Electric impulse. Action potential means electric impulse. So I draw a diagram or a graph. See here. So now this is what liminal, we have learned it. Okay, a stimuli is applied. Now action potential will be produced. So the line, blue line is what? Yes, no, Dharni Dharan, yes, very good. Yes. Now, yes, very good, ma. Now, will action potential will be produced? Minimum threshold. Jaigarni, very good, ma. Now, yes, no, very good. Now, raise your hand. I give you chance. When will it be produced? Raise your hand. When will it be produced? Yes, explain it. Jaigarni, yes. Explain.
Sir, sir, that the minimum, at least the threshold level is required, sir.
Yes, now I draw, ma. Okay, be in line. So now I draw. Now I draw, be in line. So this is one stimuli. This is second stimuli. Will it be?
Yes, sir. Now it happens, sir. These stimuli are added up and touches that line, sir.
Yes, ma, added. So two stimuli added, so that has reached threshold limit. Whether it the two stimuli should occur different time or simultaneously.
So simultaneously it occurs, sir.
Yes, the condition is what? The two stimuli should occur simultaneously, so that the two stimuli can be added. So that that will reach what? The threshold limit. Yes, very good. Very good, ma. Yes, good. So likewise, what? So below the threshold, so if we apply the stimuli, so for which no action potential will be produced. Below that, so this is what? Threshold. Threshold, that means what? The required level of what? Membrane potential. The required level of membrane potential by which the action potential can be produced. So one thing you can understand about it. See, you go for a bus journey. So 45 tickets, 45 seats will be there. So you alone has climbed into the bus. So will the driver start the bus? You alone only. You alone has climbed into the bus. No. So at least 50% or 75% of seats should be what? Filled. Am I right? At least 50%, yes, 75%. Otherwise, the journey will not be a profitable one. Yes, Ashwath, Saranjeevi, yes. So that is what? All or none principle. Salvadarshini, yes. All or none principle. So the stimuli that has to reach some level. So that is known as what? Threshold. So threshold potential. That is what? Minus 55. Yes, that is what? Minus 55 millivolt. Yes, that is what? Minus 55 millivolt. Got it, ma? Yes, Sanghavi, yes. Okay, so the resting potential now recall. So what is the resting potential? What is the resting potential here? Here, what is the resting potential? Yes, minus 70 millivolt. Yes. So the resting potential minus 70. Now a stimuli is applied. So the stimuli that changes the membrane potential to what? Minus 70, minus 60, minus, so likewise, minus 55. So now it reaches to minus, it reaches minus 55 millivolt, the membrane potential. So this is called as what? Threshold. So in this particular membrane potential only, what will happen? Action potential will be produced. Yes. Action potential. Here action potential means simply what does it mean? Action potential means Yes, Selvadarshini, very good. Electric impulse. Yes. Jaigarni, yes. Dhanushri, yes, ma. Very good. So below the subthreshold, subliminal action potential cannot be produced. So this is about what? Yes. So this only we are going to discuss. So for the conduction of the electrical impulses, action potential should be produced. Otherwise, the stimuli cannot be transferred. So that which one produce this? So in order to change the membrane potential, what is needed? So the movement of sodium and potassium ions. So already I told you. So outside, what will be there? Electropositive. Inside, electronegative. Yes, electronegative. Reason, can anybody explain? Reason, now I give chance to Dharnidhar. Okay. Okay. Jekia.
I know.
Jekia.
Yes, sir. Sir, in resting means inside the axoplasm there will be potassium, sir. It is highly permeable to potassium, sir. Along with the potassium, there will be electric charged ions, sir. Inside the axoplasm, it will be electronegative, sir. Outside of the axoplasm, there will be some sodium, sir. The sodium is positive, sir. Outside it will be electropositive, sir. The resting of it is minus 70 millivolts, sir.
Yes, very good. Okay. So now the membrane potential should what? Change. So in what way it is changed? Okay, Dharnidhar next. Okay. Yes. So in what way that is changed? So that we are going to discuss. So at first, similarly, the membrane is impermeable to negatively charged proteins present in the oxoplasm. So always the negatively charged protein remain inside the oxoplasm. That will not move outside. Just like potassium and sodium. So that, the exchange will not happen. So always the negatively charged proteins remain inside. So inside electronegativity is what? Maintained. Then consequently, the oxoplasm inside the oxon contains high concentration of K+. So 30 times, imagine it, students, outside sodium 14 times only. But even though 30 times more concentration is maintained inside the oxoplasm, due to the presence of negatively charged ions, that seems to be what? Negative, electronegative. Okay, yes. So next one. In contrast, the fluid outside the oxon contains a low concentration of K+, a high concentration of Na+. That means what? 14 times Na+. So K+, low, when comparatively low. But inside 30 times, outside when compared to the sodium, potassium ions are very low. Outside, okay, not inside, yes. Yes, ma, very good. Less than 30 times. Yes. So a high concentration of sodium and thus form a concentration gradient. So this can bring about concentration ionic gradient. These ionic gradients across the resting membrane are maintained by active transport of ions by the sodium and potassium. So now only what's happening? Now only see. Regarding the exchange of the sodium and potassium ions, 3 sodium ions that move outwards for 2 potassium ion into the cells. So during resting time, so what happened? One stimuli that already applied, one particular stimuli that was applied already. So now the membrane is reversing to resting potential. Now what's happening? 3 sodium migrate outside. So for what? 2 potassium inside. So reason is what? 3 sodium migrate outside, 2 potassium into the cell. Reason is what? No. Outside, how much of concentration sodium? 14 times. Yes, 14 times. Yes. Inside, what's the concentration of the potassium? 30 times. So outside 3 sodium moves. Inside 2 potassium moves. Yes. So what happens? More potassium, more sodium move outside. Less number of potassium enter inside. So this happens. So this can bring about what? The membrane potential into what? Electronegative. Electronegative. Okay, so 3 sodium, if, for example, students, after the stimuli is applied, inside the oxoplasm, what is found? 3 sodium, 2 potassium. So now see 3 sodium plus 2 potassium. 5 positively charged ions are inside the oxoplasm. 5, I mean, after applying stimuli. So now the membrane reverse to what? Membrane potential. I mean, resting potential. So 3 sodium rapidly goes out by sodium potassium bump. So because the membrane is not permeable to what? Sodium. So only by the opening of the sodium potassium bump, sodium ions can what? Go out. So 3 sodium ions go out. So instead of that, 2 potassium ions move in. So what will happen? So inside the oxoplasm, negative charge is maintained because more positive ions go out. More positive ions go out. Okay, but the number of potassium ions maintained inside, that is what? So what happens? After the completion of the stimuli, so the polarity is what? Reversed. Polarity is what? Reversed, because the more electropositive condition that was established inside the oxoplasm is reversed now. Now it becomes as what? Electronegative. It becomes as what? Electronegative. Did you understand it? Understand it? Okay. Did you understand it? Yes. Karthi, yes. Very good. Who will explain? Who will explain this? Who will explain? Good. Very good.
Sir. Sir.
Yes, no, proceed.
Yes, sir. Sir, whenever the stimuli is applied to the neuron, sir, there are 5 positive electrons inside the neuron, sir. There are 3 Na plus and 2 K plus, sir. Sir, whenever it coming to the resting state, rapidly 3 sodium ions get out, sir.
Get out. Very good.
There are only 2 positive ions inside there, sir. Sir, outside the more positive concentration, sir, 14%, sir. Inside 30% of the negative concentration is there, sir.
No, inside 30 times potassium concentration.
Potassium concentration, sir. Because of the low positive ions present inside, sir, it leads to the electronegative, sir.
Yes.
Outside the more positive present, so it leads to electropositive, sir.
Yes, ma. See, 5 positive ions are inside the oxoplasm. So what happens? Electropositive condition is maintained.
Yes, sir.
So now the polarity should be what? Reversed, so that only 3 sodium ions that move out, but 2 potassium ions enter into the cells. So now positive is exchanged, but the number of positive ions exchanged, that is different. So this is for what? To reverse the polarity. Okay, ma?
Yes, sir.
For 3 sodium ions, 3 potassium ions is exchanged, same number, same charge will be established. Am I right? Same charge only established. Am I right, ma? Yes.
Yes, sir.
Students? Yes, Ashwati Nakma. Okay.
Thank you, sir.
Yes, ma. Yes. So that only, so 3 sodium ions that move out, for that 2 sodium ions enter. 2 potassium ions easily enter through membrane, permeable membrane. But 3 sodium ions, for that sodium potassium ionic channel should be open. Okay, so I mean the number of molecules that move in and out, that vary. So polarity will be what? Reversed. Polarity will be reversed. So now once again the membrane potential comes as what? Electropositive. Once again the membrane potential comes as what? Electropositive. Here electronegative. So if you apply a stimuli, what will happen? So once again this will comes to electronegative. This will come as what? Electropositive. So here simply yes, positive. Madhushri, yes, no. Okay, yes. So this is about what? Polarized and depolarized. Yes, Ashwath, in out manner. Yes, ma. Yes. Next one, in neuron, the resting membrane potential ranges from minus 40 milliwatt to minus 90 milliwatt, average minus 70 milliwatt. So don't forget this. So not exactly minus 70 milliwatt, that may vary from person to person. So average minus 70 milliwatt. Okay, so what is the threshold? That is minus 55 milliwatt threshold. So at the threshold limit only, so the action potential can be propagated. Yes, Harshida, very good. Minus sign indicates that the inside the cell, that is electronegative. Inside the cells electronegative. Even though potassium ions are there, the negatively charged proteins that bring about, that confer, that render the negative charges. Okay, yes. Next one, as a result, the outer surface axonal membrane possesses a positive charge, while its inner surface becomes negatively charged. This condition when? Before applying stimuli or after applying stimuli? Chat to me, students. This condition is when? Before applying stimuli or after applying stimuli? No. Before, see, axonal membrane, electropositive outside. Before, okay, yes. Before applying stimuli, outside what? Electropositive. Yes, very good. See, now I show you. You can see here. So outside what's found before applying stimuli? Resting action. See, outside what charge is there? What charge? Plus, Dharnidharan, yes, very good. Plus charge, yes. Before applying stimuli, resting means what? After applying stimuli or before applying stimuli? After applying stimuli, yes. Before, yes. Okay, ma, yes, very good. Before. So outside positive, yes. Next one, stimulus. Stimulus is applied. Now stimulus is applied. Oh, so this condition polarized. This condition is what? Polarized. Now here you can see depolarized. What happens? What happens outside? What is charges? Outside what charge? Positive or negative? Very good. Outside. Outside. Now stimulus is applied. Yes. Negative charge. Very good. Outside negative charge. So reason is what? Reason why? Yes. Entry of what? Sodium ions. Yes. Yes, ma. Entry of what? Sodium ions. Very good. Entry of sodium ions. So now it is permeable to sodium ions. So which allow the sodium ions to enter into the cell? Which allow the sodium ions after applying stimuli? Which not axolema, but which part? Sodium potassium bomb ionic channel. Very good. Sodium potassium ionic channel, that is highly, now it is permeable to allow the sodium enter into the oxoplasm. Very good. Yes. So now inside what is formed? Inside the oxoplasm, positive or negative? Here after applying stimuli, inside electropositive or yes, positive. Selvadarshini, yes, very good. Sumana Azin, Harshida, Jakia, Madhushri, Ashwath. Inside what is formed? Electropositive is formed. Yes. So now, yes, what will happen? The polarity has been changed or not? The polarity, whether it has been changed or not? Yes, changed. Yes. So now what will happen? So the current flow occurs. Saranjeev, yes, very good. Shruti Krishna, very good. So now what will happen? The current flow occur. Okay. So here positive. So yes, here positive. So from positive to negative, one current flow occur. Current flow. Positive to negative. So this is what? The transfer or conduction of what? Electric impulse. Got it, student? Got it? Yes, conduction or impulse from positive to negative. So what happens? The flow of current, that happens. Current flow, that is what? Conduction of what? Impulse. So current flow means what? Conduction of impulse. Yes, flow of current. Impulse is what? Electric impulse. Because action potential means electric impulse. So electric impulse conducted. Yes, current flow means electric impulse is what? Conducted. Yes. So likewise, so this is one. So this is known as A site. This is known as what? A site. Likewise, take second site, B site. Here also the same thing happen. So this one comes to what? Repolarized state. Now this is called as depolarized. This one comes to B site, comes to what? Depolarized. So here also what happens? Here also current flow happens. So from here to here, likewise, current flow happens. Sorry, from here to here, current flow happens. Current flow. So likewise, outside the membrane from B site to A site, likewise. So the circuit is what? Completed. Got it, student? So this one A site, this one B site. So inside, likewise. Outside from terminal to initial. From terminal to initial. Likewise, the flow will be there. So this is for what? To complete the circuit. Okay, so now say chat to me. So outside of the membrane, from which side to which side current flow occurs? Outside of the membrane, from which side to? Two sides are given. Yes, B to A, very good. Madhusri, Selvadashni, yes, very good. So Selvadashni are also correct. Positive to negative, simply, that is all. Selvadashni correctly told. Positive to negative, that is all. Okay, yes. Outside from B side to A side, inside from A side to B side, that is all. Madhusri, yes. Jaygarni. So from positive to negative. Outside also from positive to negative. Karthi, yes, very good. Yes, Karthi, yes, very good. So this is about what? The conduction of electric potentials. Now once again we can see. Okay. So as a result, the outer surface, Jaygarni, positive always remain inside. Yes, always remain inside. Jaygarni, positive ions always remain inside. But due to the effect of negatively charged proteins only, that seems to be negative. But positive ions always remain inside. Likewise, outside of the axon membrane, negative ions will be there. But the concentration will be what? Low. The concentration will be what? Low. Yes, ma'am. Jaygarni, yes. Okay, so as a result, the outer surface of the axonal membrane possesses a positive charge. So while inner surface become negatively charged, now the electrical potential difference across the resting plasma membrane is called as the resting potential. Now we are going to apply a stimuli. When a stimulus is applied at a site point A on the polarized membrane. Chat to me, what do you mean by polarized? Chat to me, what do you mean by polarized? Polarized membrane means resting potential. Very good. Selvadashni, yes. Krutika, very good. Yes. Ashwat, very good. Resting potential. Yes. So now at the site, the resting potential is changed. A site. Because A site, B site, C site, D site, along the entire length of the axon, many sites are there. So every site, that is what? Reversed in polarity. So at first the A site. A site, the reversal of polarity. So that is called as what? From polarized to depolarized. Polarized to depolarized. Depolarized means A site, that is depolarized initially. So here depolarized means reversal of membrane potential. Karthi, did you understand, ma'am? Madhusri, yes.
Yes, sir. Understand, sir.
Yes, ma'am. Okay. Okay, so polarized means membrane potential minus 70. Depolarized means minus 55, above minus 55. Minus 55 or above minus 55. This is called as what? Yes, Harshida Sangavi, yes, very good. So next one, so A becomes freely permeable to sodium whenever stimuli is applied. If stimuli is not applied, that condition that will not permit. Sodium ion channel that is blocked. Okay, that is blocked, that will not allow. But stimuli, if you apply stimuli, that will open, allow what? The entry of sodium. So this leads to rapid influx, not slowly. Yes, not slowly, rapid influx. Because if you touch your skin, you can sense. If you touch your skin, you can sense. So within a fraction of time, it is possible. Am I right? Yes. Within a fraction of second, it is possible very rapidly. If you touch, if you apply a hot object, so rapidly you remove your hand from that side within a fraction of time. Yes, beyond your knowledge. So that happens. Yes. So rapidly, so the sodium rapidly enter into what? The oxoplasm. So next one, so the polarity is what? Reversed. Yes, oxoplasm. Next one, the outer surface of the membrane becomes negatively charged. Okay, negatively charged, and the inner side becomes positively charged. Okay, so the polarity of the membrane at the A site is reversed and hence depolarized. So already I told you, so current flow from inside, from A site to B site, B site to C site, outside C site to B site, B site to A site. So likewise, so that what will happen? The circuit will be what? Completed. Circuit will be what? Completed. Okay. So this is about what? The electric impulses conduction. Here you can see in this image. First one, sodium potassium ionic channels closed. Okay, you can see inactivation gate. So resting potential minus 70 millivolt. So now you can see here that is blocked outside. Now that is allowed. So sodium that is allowed. So mechanism of depolarization. If it is depolarized, so that means what? That allows the sodium ions enter into the cells. This is called as what? Yes, whenever stimuli is applied, that is open. Yes, Ashwath, very good. See here, you can see how the conduction happens. Selvadarshini, yes, conduction of the electron. At first, outside electropositive, inside electronegative. Now stimuli is applied. So what happens outside? Outside that becomes, see, yes, outside that becomes electronegative. Inside that becomes electropositive. So now inside from, this is A site. So from A site to B site moves. Here from B site to A site, the electric current flow occurs. Yes. Ashwath, B to A is equal to, yes, ma'am. Yes. So this is about what? Electric impulse conduction. So next one. So during depolarization, enough sodium ions enter the cell. The membrane potential reaches certain level called threshold potential. Don't forget this, minus 55 millivolt. The particular stimulus which is able to bring the bring the membrane potential to threshold is called threshold stimulus. So now one point you have to remember, below the threshold limit, the stimuli will not produce what? Action potential. Below the threshold. So that's the only thing you have to remember. The action potential occurs in response to threshold stimuli, but does not occur at the subthreshold stimuli. So this is the thing you have to remember. So before that, we apply certain stimuli, students. So below the subthreshold, we apply certain stimuli. And that stimuli is called as what? That stimuli before minus 55. So certain not yes, subthreshold stimuli. For that, certain electric impulses are produced. For that also certain electric impulses can be produced. That is called as what? Membrane, yes, minus 70 watt millivolt. That is what? Membrane potential, not action potential. Yes. So difference is there. Yes, difference is there. Yes, who will explain this? What's the difference between the membrane potential and action potential? Who is ready to explain? Yes, Jay Garni, yes.
Sir, yes.
Yes, ma'am. Difference between membrane potential and action potential.
Sir, membrane potential is minus 70 millivolts, sir. It is below the threshold level, sir. So that time.
So what about minus 65?
Sir, below minus 70, sir.
No, ma. So minus 70, that is resting potential.
Yes, sir.
Membrane potential.
Sir, below that threshold level, there is minus 70, sir. So that time there is no stimulus is supplied, no impulses is produced, sir. So above that threshold level, there will be minus 55. When it reaches at least minus 55, then the impulses will start producing, sir.
Yes, ma'am. So below the minus 55, all are what? Membrane potential. Okay. Below minus 55, all are membrane. Yes. But minus 70, when we mention minus 70, that is what? Resting potential. Got
Yes.
it?
Yes, sir.
Okay. Correct, ma'am. Okay. So in a different way explain. So, but the meaning is correct. Okay. Okay, ma'am. So all are non-principal. So who will explain? All are non-principal. Explain. Ashwath. All are non-principal. Now I do. So raise your hand. Raise your hand. Yes.
Yes, sir. Sir.
All are non-principal.
Yes, sir. Sir, all are non-principal, sir. Sir, here threshold limit is minus 55 millivolt, sir. Whenever the threshold does not occur, the stimuli, whenever the stimuli is not occur, sir, below the threshold level means it is all or non-principal, sir.
Stimuli, when the stimuli is not reached the
above the threshold does not reach the threshold limit means.
So unless the stimuli reaches the threshold limit, no action potentials are produced.
Yes, sir.
So that is known as what? Okay.
All are non-principal, sir.
Explanation is correct. Okay, but different way you explain. That's all. Okay, ma'am.
Yes, sir.
Okay.
Thank you, sir.
Unless, very good. Okay. So unless the stimuli reaches the threshold limit, the action potential will not be produced. Okay. So this is about what? All are non-principal. So I explain you with an example. So in a bus journey, if you get into a bus, so the driver will not start the bus. I mean, if the bus is filled to 50% of passengers or 75% of passengers, so 50% of passengers are needed. If you go for a long journey, so otherwise it will not be profitable. So this is what? Now all are non-principal. Next one. So due to rapid influx of sodium ions, the membrane potential shoots rapidly up to plus 45 milliwatt. So action potential, in order to propagate action potential, minus 55 or above minus 55, that is enough. Okay. So if so if we beat fast, so that is one stimuli, the strong stimuli. Okay, so I gently place my hand on the skin. So this is one stimuli. If I beat, so that is one stimuli. So that may increase up to what? Plus 45 millivolt. That can mean, but minimum. So that is what? Minus 55. Got it, students? Yes. Both also above minus 55. Yes. Jai Garni. So at first, rapidly, because sodium ions, whenever the, see, dam is there, students. Okay. If the dam is broken, what will happen? Or the gate is what? Removed. So what will happen? The shutter gate is what? Removed. So what will happen? Yes, water gush out with the greater force. Yes, water, yes, gush out with a greater force. Yes. So likewise what? So now sodium potassium ionic channel is what? Blocked. So after the application of stimuli, so that opens. Yes. So rapidly sodium ions enter in. So the membrane potential, that is greatly changed. So what is that? What is that? Plus 45 millivolt. Yes. Membrane potential is changed. Yes. This is known as what? Spike potential. Increased. Yes. This is known as what? Spike. Spike means spike. Peak level. Okay. Spike. Peak. So spike potential. Got it? Yes. So here we have discussed 3 types of potential. Who is ready to say 3 types of potential we have discussed? Who is ready to say? Who is ready to say? Ashwin, are you ready, ma? Madhushri, Prabhashini, are you ready? Rajashri, what happened? Rajashri, are you ready? Yes. Madhushri, yes, ma.
Yes, sir. Happy afternoon, sir.
Yes, ma. Good afternoon, ma.
Sir, when it reaches above the threshold, it is action potential, sir. When it is below threshold, it is membrane potential, sir. And when it is at minus 70 MV, it is resting potential, sir.
Very good. Okay. Enough.
Thank you.
Okay, thank you. Okay, so spike potential plus 45. Don't forget this. Next one, the electrical potential difference across the plasma membrane at the site A. So we got discussed. So site A, site B, site C, site D throughout the entire length of the axon. Now we have taken 2 sites only for our understanding. Site A is called the action potential. So site A, if membrane polarity is changed, outside usually positive, inside usually negative. If this is changed, that means what? That is depolarized. A site, if a polarity is changed, that means what? Depolarized. So which is in fact termed as nerve impulse. Now say students, 2 sites we have taken, A site, B site, C site. Now electric current flow occurs from A site to B site. So now from second, B site to C site. Now what is the condition in A site? Whether polarized, depolarized or repolarized? A site to B site. So what occurs? A site to B site, one electric current flow occurs. Second, B site to C site, second electric current flow. Now what about the fate of the A site? A site, that is what? A site that comes to, that is repolarizing. Very good. Yes. Selvadashni, yes, very good. Abhinitya, yes, very good. Now it is what? Repolarizing. Very good. Repolarizing. Depolarized means repolarized. Yes, very good. I mean, sodium potassium ionic channel. Okay, so I mean, ionic pump, that is what? Operative, in operation. That is what? Repolarized. Completely closed. That means what? Polarized. So in resting time that occurs. After all the stimuli are applied, resting time that occurs. So now repolarization is going on. So A site to B site, yes. Now A site remains in what? Repolarized. Repolarized means once again that is getting the normal state. Getting the normal state, not attained. If it is attained, that the condition is called as what? Polarized. But that is going on. Going on means repolarized. Got it, students? Got it? Who will explain this? Polarized. Becoming normal. Yes, trying to become normal. Process is going on. Not finished. So that is known as what? Repolarized. So now I hope you have understood the meaning of all these terms. Who will explain this? Yes, who will explain this? Who is ready? Polarized, depolarized, and repolarized. Who is ready to explain? Who will explain? Jai Garni, yes, no. Okay.
Sir, polarized means it is completely at rest time, sir.
Yes.
Depolarized means during that the stimuli is supplying, that time happening is depolarized, sir. And repolarized is it is in the process to come to normal state, sir.
Trying to come normal. Yes.
State,
Very good. Okay. Enough, enough. Okay. So now see. So this occurs to what? Complete the circuit. That means what? A side to B side, the current flow. Hence, the polarity at the site is reversed and an action potential is generated at site B. So likewise, a chain of reaction happening. So one by one. So likewise. So that's the impulse generated at site A arrives at B. So outside that there one current flow, inside one current flow. Outside the oxoplasm one current flow, inside the oxoplasm one current flow. So that occurs. So this sequence is repeated along the length of the axon, because A side, B side, so likewise, entire length of the axon. So, and consequently the impulse is conducted. The rise in the stimulus induced permeability. The rise in the stimulus induced permeability. Here, what does it mean? The rise in the stimulus induced permeability. For which ion? For which ion? Sodium or potassium? Yes, sodium ion. Selvadashni, very good. Yeah, the rise in the stimulus induced permeability to what? Yes. That is what? Due to what? Sodium ions. Very good. Yes, if stimuli is not applied, no entry of sodium ions. Very easy to remember this. Dharnidharan, yes. Okay. So extremely short-lived. Why short-lived? Why short-lived? Because so after the stimuli is applied, so once again that goes to what? The outside. So for that 3 sodium ions, yes, 3 sodium ions should go outside. Okay, so entry of sodium ions during stimuli. Yes. So after the electric current is created, the flow of electric current is completed, what should happen? Immediately it should go out through the sodium potassium ionic, through the sodium ionic channel. Yes. So 3 sodium goes out, 2 potassium enter into the cell. Yes, 2 potassium enter into the cell. So short-lived. Got it, students? Short-lived. Within a fraction of time, stimuli is applied, everything happens. Polarization, depolarization, everything happens. Yes. Okay, got it. So it is quickly followed by rise in permeability to potassium. Within a fraction of second, K plus diffuses outside the membrane and restores the resting potential of the membrane at the site of excitation, and the fiber becomes once more responsive for the stimulation. Now, negative potentials has been what? Established. Negative membrane potential has been established. So now once again, it is ready for what? Stimulation. It is ready for what? Stimulation. So these are all about what? So the transmission of, the transfer of what? The electric impulses. So how the electrical impulses are produced, how they are what? Transferred. So 3 states we got discussed. So regarding this, I want to show you a short video clip so you can understand it clearly.
It could be discussed for hours upon hours, but let's go over a very basic summary here. First, we must understand the concept of membrane potential. For a more
so how electric impulses are produced and conducted. So regarding that, this video
rigorous discussion of electric potential from a physics standpoint, check out my tutorial on that subject now. Otherwise, for our purposes here, we just need to know that opposite charges attract. So if there exist opposite charges near one another, work must be done to separate them. If these regions are already separated within a cell, there is an opportunity to use the potential energy that exists by virtue of their separation. This charge separation exists within nerve cells due to the concentrations of specific ions that sit inside and outside of the plasma membrane. So we say there is a...
So you can see outside positive charge, you can see. Inside you can see, here you can see. So this is what plasma.
Are bipolar neurons, which have two processes. One, gated channels, concentrations of specific ions that sit inside and outside of the...
Okay, here you can see outside positive ions. So this is what plasma membrane. Inside you can see. So negative membrane. Here plasma membrane means oxolemma. So we had discussed. Okay.
Plasma membrane. So we say there is a potential difference across that membrane, and the membrane itself resists the current flow, as formally charged ions have difficulty traversing the nonpolar section of the membrane. However, there are ion channels in the membrane which can allow specific ions through at specific times.
You can say ionic channel. So for the entry of what? Sodium.
Some of these are non-gated, meaning they remain open. Others are gated, meaning they are closed and only open as the result of a particular signal. Chemically gated channels open when a specific neurotransmitter binds. Voltage-gated channels respond to changes in the membrane potential.
So this voltage-gated channels that is found in notes of Ranvier. Notes of Ranvier.
And mechanically gated channels open when the receptor becomes physically deformed. When these channels open, ions can freely diffuse through, obeying the electrochemical gradient, which seeks to balance charge, so an electrical current is generated.
Now you can see sodium that move out and move inside and out, potassium channel that through which also potassium move in and out.
A resting neuron has a resting membrane potential based on the sodium.
So now see the resting potential. So the voltmeter that shows you what? Minus 70 millivolt.
Potassium ion concentrations in and out of the cell due to their differing abilities to diffuse across the membrane. And it is maintained by sodium-potassium pumps that keep the concentration gradient as it is. But when a signal is received, whether from sensory input or a neurotransmitter from another neuron, there will be a change in this potential which can produce a signal. This signal will be either a graded potential, which operates over short distances, or an action potential, which operates over long distances, like the length of an axon. In the latter case, depolarization must exceed a particular threshold, meaning sodium channels must open and a sufficient number of sodium ions must diffuse into the cell. But if achieved, a nerve impulse will result, and a current will propagate along the axon towards the axon terminals. Repolarization will then occur where voltage-gated potassium channels allow potassium ions to exit the cell, which leads to a brief hyperpolarization, and then everything resets to original levels and position.
Hyperpolarization, repolarization, hyperpolarization. So that is what? So we had discussed minus 70 average, that is resting potential. So before that, that goes up to minus 90 millivolt. So here minus 90 millivolt is what? Hyperpolarization. Then that one comes to what? Minus 70 millivolt. So this is resting potential. Okay. So this is what? Resting potential. So if you run fast, students, if you run fast, so suddenly you are asked to what? Stop. So behind a line. Suddenly you are asked to stop behind a particular line, grease. So what will happen? You will fall. So you will fall, front. So you will fall front. So like, you can't stop yourself. So you will go beyond the grease. So you will, you will overpass the grease. So that will happen. So likewise, minus 70 normal, but the speed that reversal that occurs very speedily, so that goes to what? Minus 90. So then comes to what? Minus, return once again comes to minus 70. So this minus 70 is what? Resting potential. So hyperpolarization, for that I explained.
As for the impulse, when it reaches the axon terminals and neurotransmitters are released, these enter the synaptic space. A synapse is a junction between neurons or between a neuron and an effector cell. This is where communication happens. These synapses can be axodendritic, axosomatic, or axoaxonal, depending on where the axon terminals from the presynaptic neuron connect to the postsynaptic neuron. So that covers the basics regarding the action potential. We could get much more detailed and quantitative than this brief description, and perhaps we will dig a little deeper later in the series. But as we are currently focused on the big picture, let's be satisfied with this rudimentary understanding for the moment. Now that we know a bit about the structure and function of a neuron, let's discuss
Okay, students. So this is about So Jakia, lower your hand, ma. Okay, students. So we have discussed about what? So the conduction, so the propagation and conduction of what? Electric impulses. Conduction and propagation of what? Electric impulses. Yes, ma. So now let's recall the points now. Okay, recall the points now. So now classification of neurons. So at first afferent, efferent. So afferent means what? So which part of the neuron that receive the stimuli? Yes. Which part of the neuron that receive the stimuli? Yes. Dendron. Very good, ma. Karti, Subhashri, Abhinitya, Salvadarshini. Yes. Very good. Shruti Krishna. Yes. Dendrites. Yes. So next one, axon. So regarding the axon, so that is what? Whether afferent or efferent? Yes, efferent. Ashwath, very good. Ramya Devi, yes. Harshida, Salvadarshini, yes. Very good. Afferent. Yes. Then most of the organelles are found in the dendrons. Most of the organelles are found in the dendrons. Okay. So likewise in axon, what are all the organelles are not found? What are all the organelles are? Yes, Nissl granules. Next one. So organelles means yes, Nissl granules. Yes. Next one. Yes. Rough endoplasmic reticulum. Yes. Very good. Golgi complex. Yes. Very good. Ribosome. Yes. Very good. So all those organelles are not found. Okay, student. Yes. All those organelles are not found. So endoplasmic, rough endoplasmic reticulum, ribosome, and yes, Golgi complex, Nissl bodies. Yes, all are not found in what? Axon. Very good. Then yes, ma'am. So next one, classification. Neuron. So first one, afferent and efferent neurons we have discussed. Second classification based on what? Second class, yes, presence of processes. How many axon and how many dendrons? Yes, unipolar neuron is found in. Yes, unipolar neuron is found in. Unipolar where? Yes, embryo. Yes, ma. Very good. Embryo. Yes. Yes, ma. Embryo. Very good. How many dendron is there? How many dendron in unipolar? Yes, very good. No. Okay, yes. No dendron is there in unipolar. Yes. So what is found? Yes, axon alone. Yes, very good. Axon alone. Yes. So what is the difference between unipolar and pseudo-unipolar? What is the difference between pseudo-unipolar and unipolar? Unipolar that found in what? Adult. Very good. Yes, ma. Yes, Salvadarshini. Yes, very good. Ramya Devi, very good. Pseudo-unipolar that found in what? Adult. Which part of the adult? Which part of the adult? Which part? In adult, which part? Dorsal root of ganglia. Selvadarshini, yes, very good. Jaigarni, very good. Yes, dorsal root of ganglia. Shruti Krishna, yes, very good. Dorsal root of ganglia, very good. Okay. Then multipolar. Why we are calling that as what? Unipolar, pseudo unipolar. Why we are calling that as what? Pseudo unipolar? A single process arises from axon. Yes. So which can act as what? Dendron. Yes. Which can act as what? Dendron. Hence we are calling that as what? Yes. Pseudo unipolar. Very good. Bipolar. Bipolar found in Cartius. Very good. Bipolar found in Dhanushi. Yes. Retina. Very good. Bipolar is found in retina. Yes. Very good. Very good. Yes. Amacrine cells. Amacrine cells are found in, yes, amacrine cells are eye. Very good, very good. Yes. Next to the photoreceptors. Yes. So what is the function of amacrine cells? What is the function of the amacrine cells? Amacrine cells function? Amacrine. Shritika, not detoxification. Yes. Conduction. Yes. Receive the impulses from what? Bipolar neurons. Receive the impulse, conduction of the impulses between two neurons. Yes, ganglion cells, very good. Abhinitya, very good, I appreciate you. So receive the impulse from bipolar neuron and transfer it to what? Ganglionated cells. Okay, ganglion cells. Yes, very good. Ganglion. Yes, Sangavi Ramya Devi. Yes, very good, ma'am. Yes. Yes, very good. Very good, students. Yes. So next one, multipolar neurons. How many dendrons? Multipolar neurons. How many dendrons? Yes, more than 2. Very good. Yes, more than 2. Very good. Yes, ma. Shritika, Salvadarshini, Sujida. Yes, everybody. Dharni Dharans. Yes, very good. Ma. Subhashi, very good. Okay. Then synaptic cleft. Synaptic cleft. So that is found between. Synaptic cleft, that is found between yes, two neurons means axon terminal and dendrons. Yes, axon terminal or dendron of the, yes, next neuron. Very good. Yes, Salvadarshini, yes, very good. Yes, multipolar neuron. Example, multipolar neuron. Example, where can we? Yes, Shruti Krishna, yes, neurons found in cerebral cortex. Very good. Harshida, very good. Yes. Ashwath, very good. Subhashri, very good. Yes. In autonomic nervous system, what type of neurons are found? In autonomic nervous system, Ashwath, autonomic nervous system, what type of neuron? Yes, non-myelinated. Yes, very good. Salvadarshini, very good. Dharnidharan, very good. Yes. In somatic nervous system, what type of? Yes, Karthi, very good. Yes, ma, very good. Sumana Hazin. Yes, somatic neural system, non-myelinated. Very good. Yes, ma. Very good, very good. Okay. Ranjit Kumar, Dharnidharan, very good, ma. Yes. Regarding the propagation of the electric impulses, so what is the threshold stimuli? What's the threshold potential? Yes, minus 55 milliwatt. Yes, very good. So yes, if I say that is minus 45, very good, Karthias. If I say that is minus 45, now this is called as what? This potential minus 45. Salvadarshini, minus 45. I say, yes, very good. That is what? Membrane potential. Very good. Membrane potential. Otherwise, membrane potential, otherwise what? Yes, not resting. Yes, subthreshold. Yes, very good, ma. Subliminal. Yes, potential. Subliminal potential. Okay, very good. Yes, membrane potential or subliminal potential. Very good. Yes. Next one, minus 90 millivolt. Minus 90 millivolt is what? minus 90 millivolt. Yes, very good. Abhinitya, correct. Okay, Salvadarshini, Ranjit Kumar. No, not resting potential. Hyperpolarized state. Okay, hyperpolarized state. Yes, Sanjeev, yes. Shruti Krishna, resting potential means minus 70. At first that goes up to minus 90. Yes, that is known as what? Yes, hyperpolarization. Very good. Yes. Next one, after the application of stimuli, gradually the ionic gradient comes to normal. This state is known as what? Gradually the ionic gradient comes to, yes, Jaiharni, Abhinitya, very good. Ashwath, very good. That is what? Repolarization. Very good. Okay. So in a resting membrane potential state, so what is the outside? What is the charge found in the outside of the oxoplasm? Positive, very good. Yes, very good. Usually outside what will be there? Which ions will be there? In more concentration, sodium, very good. Okay, yes. Inside potassium ions, yes. Inside electronegative, yes, very good. Okay, the sodium ions enter into the cell through what? The sodium ions enter into the cell through what? Yes, ionic channel, very good. Yes, ionic channel, very good. Karthi, yes. Dharnidharan, yes, very good. Ionic channel, very good. Okay, ma. Very good, ma. Okay, yes. So now, when the stimuli is applied, so what happens to the ionic channel? What happens to the ionic channel? Sodium ionic channel, yes, very good. Jaiharni, yes, open. But in some other time, when stimuli is not applied, what will happen? Yes, that is what closed. Then whether potassium ions that is only move through the potassium ionic channel or some other way. Whether that moves, yes, oxolemma, yes, non-gated, yes, ionic channel, very good. So that in that video we got seen, yes, non-gated ionic channel. So oxolemma is highly permeable to Oxolemma is highly permeable to, yes, very good. Potassium ions, very good. Potassium ions, very good. The exchange, how many ions are, sodium ions are exchanged? How many sodium ions? Yes, very good. Very good, ma. Yes, very good. Yes, very good, student. Yes. So then the conduction site that is restricted to, restricted to the conduction site. That is restricted to which part of the neuron? Conduction site. Which is restricted to which part of the neuron? No, axon that to the entire length of the axon conduction that happens. Entire length of the axon conduction happens. So neuronal part, which part? Say cyton, okay. Cyton and mean dendron receive. So axon what? Conduct it. Yes. Dendron, cyton, dendron that receives, conduction happens in what? Yes. So restricted part what? Yes. Yes, ma. Cyton, axon through the entire length of the axon that happens. Yes. So ma. Very good. Yes. Very good, ma. Then myelinated neurons, the saltatory conduction occurs where? The saltatory conduction occurs where? Myelinated neuron, saltatory conduction. Yes. So here the gap between the gap of the nodes are Ranvier. Do you know? The gap, the distance of the gap of the nodes of Ranvier. Between the two myelin sheath, the gap is found. That is called as what? Nodes of Ranvier. Yes, very good. Selvadarshini, yes, very good. That is 1 micrometer. Very good. Yes. The speed of conduction of non-myelinated neuron. The speed of conduction of non-myelinated. How many miles? Yes, 1 mile per hour. While myelinated is what? Myelinated 285 miles per yes hour. Okay, ma. Yes, yes. Okay, students. Yes. So if you got any doubt, you can ask. Okay, ma'am. So if you have any doubt, you can ask me. Okay, students, you answer very well. So if you have any doubt, you can ask me. Do you have any doubt? Shall we pass to poll test? Otherwise, okay, my poll test question has been launched. First question, statement 1, oxoplasm inside the axon contains more negatively charged proteins. Second question, sodium potassium bomb that transport how many sodium outwards for how many potassium into the cell? Third question, polarity change in neuron is due to in neurons, threshold potential and resting potential are dash respectively. Fifth question, which is wrong statement? Okay, students, now I call your name. Abhinitya.
Yes, sir. Statement 1. Axoplasm inside the axon contains more negatively charged proteins. Statement 2. The resting membrane potential is 450 millivolt. Sir, 1 is true, but 2 is false, sir.
False. Very good, student. Very good. Yes.
Yes, sir.
Second.
Yes, sir. Sodium potassium pump that transport 3 sodium outward for 2 potassium into the cell, sir.
Yes, ma. So C option. Okay, ma. Yes. Okay, enough, Abhinitya. Thank you, student. Next one. Jakia.
Yes, sir.
Yes.
Polarity charge in neuron is due to transport of sodium and potassium ions, sir.
Transport of sodium. Yes, ma. Very good. Correct answer. Yes. Enough, Jakia.
Yes, sir.
Thank you, student. Okay. Next one. Dharan.
Yes, sir. Am I audible, sir?
Audible. Fourth question.
Yes, sir. The fourth question, sir. The neuron's threshold potential and resting potential are minus 55 millivolt and minus 70 millivolt respectively, sir.
Yes, ma. Yes. Okay. So last question, ma.
Sir, which is one statement. The second, sir, action potential can be even produced at the subthreshold stimuli, sir.
Yes, ma. So before that, we call that as what? Membrane potential, not action potential.
Membrane potential, sir.
Yes, ma. Okay. Very good. Okay.
Thank you, sir.
Okay. Thank you, student. Okay. Thank you, students. Thank you, sir. For remaining students, next class I will give you a chance, ma. Okay. Okay. Thank you, sir.